Hello, our most developed student. My name is Confident and welcome to our 24-minute lesson. This is the ultimate guide in maths, science, career guidance, as well as a sneak peek in my personal experiences. This is a channel that is designed with you in mind. Let us dive into today's lesson. As we continue with our lesson on organic chemistry, the ultimate guide, in this particular lesson, we are looking at the reactions in organic chemistry, and we're going to look at a couple of reactions, which are the oxidation, esterification, addition reaction, elimination, substitution, as well as polymerization. So this is one of the most important sections that you need also to get hold of, because it covers or it carries good marks in your final exams. So when we are talking about the first one, which is the oxidation of I would say alkanes here, because mainly we are going to focus only on alkanes and not the other part. Your syllabus only limits to alkanes. So when you're looking at the oxidation of alkanes, what does it mean? The word oxidation means the combustion of alkanes in oxygen. So whenever we're talking about oxidation, meaning oxygen is involved. Now the word combustion is to burn. It is the burning of oxygen of alkanes in oxygen. And then these the moment alkanes are being oxidized, or when they are burning, we are saying that they are being used as fuels. So now if you look at the use of alkanes as fuels, we're saying alkanes are highly combustible, meaning they are very flammable, or they easily burn, and are valuable as clean fuels, burning to form water and carbon dioxide. Remember that whenever a fuel is burning, in this case the alkanes, you form two things. The products are water as well as carbon dioxide. But when they say incomplete combustion, there is another compound that is formed, which is carbon monoxide. I will talk briefly about this, but I don't want you to focus on that. But the key ones is water and carbon dioxide, H2O and CO2. Now, the common fuels or the common alkanes that you'll be dealing with is methane, which is usually found in most of these gas bottles. You discover that these gas bottles, like the easy gas here, they use methane. That's the gas that you find in stoves. For cooking, they use methane. And then also ethane, propane, and butane are the gases and used directly as fuels. And then another word that is common is the liquefied petroleum gas, LPG, which is made up of a mixture of propane and butane. The liquefied petroleum gas is also another mixture that you can find in these gas bottles. So whenever they say uses of alkanes, don't forget they are used as fuels, and the common one is the methane that is used as a combustion gas. That is that part. So remember that. Now when we talk about the actual combustion here, to say combustion of alkanes in excess oxygen. Now the word excess oxygen is very important, because when they are saying incomplete combustion, that's when we get a different product. When they're saying in excess oxygen, so what you will have alkane and then plus oxygen. Let me actually write the word to say oxygen, and in bracket we're saying here it is in excess. What are you going to form? You are going to form water plus what? Plus carbon dioxide, plus what? Plus heat. Don't forget that, plus heat. So it's a lot of heat. That's why we are using these as fuels, because they produce a lot of heat. And usually we say this reaction is delta H is less than 0, meaning what type of reaction this is an exothermic reaction. Very important, because you need to also put that. Then exothermic reaction, why? Because this reaction produces heat. or delta H is less than 0. It's exothermic. So that's why they are used as fuels, because they produce heat. Now, if I'm to write this reaction in like a chemical reaction, what you are saying, let's think of a simple alkane. The first one we said, the first 4 is methane. So if I take methane, in this case, methane, remember, is like this, is H, H, H. So that's the structure of methane, but you're not going to write it like that. You're going to write it as the molecular formula, which is CH4, right, plus oxygen. I said, what do you produce? You produce water, H2O, plus what? Carbon dioxide. Always remember these products. Water plus carbon dioxide. Of course, you can say plus heat. You don't have to balance on the heat. Now, when you're talking about these, you need to balance this equation. Now, you need to know the technique of balancing, which you did in grade 11. But what do you do first? The first thing that you have to do is to focus on your oxygen. Now, the oxygen that you're going to focus on is on your left hand side, this side, your right hand side. Let's focus on oxygen. How many oxygen do we have? For the water, we have got only 1 oxygen, because there is a 1 there, so it's 1 oxygen, plus for the carbon dioxide we have got O2, so which means there are how many? There are 2 oxygen. There is a 1 there, 1 times 2, which is 2 oxygens. If you add these 1 plus 2, we have got 3 oxygen atoms. But on the left hand side, we've got how many oxygen atoms? We have got only 2 oxygen atoms. But now, if I want to make 3 oxygen atoms, I'll put 3 there, which means 3 times 2, though this becomes 6, right? So if I want to make 3 oxygen atoms, what do? I divide by 2, which is 3 times 2 divided by 2. So it's 3 times 2 divided by 2. Look what I have. I've got 3 oxygen atoms, which means oxygen in a way has balanced. I hope you saw what I did. I have managed to balance the oxygens on my left hand side. Let me do this. Left hand side and right hand side. So oxygen, I've got 3, and here oxygen, I've got 3. Right. And of course, we're not going to leave our answers as 3/2. It doesn't make sense, but you'll see where I'm getting into. Now, let's come to balance our carbon. We've got 1 carbon, which is fine. So we've got 1 carbon on the left hand side with the methane, and the carbon dioxide is 1 carbon. So far so good. But the hydrogen, look at the hydrogen. I have got 2, 1 times 2 on the right hand side. I've got 2 on the right hand side, 2 hydrogens, but I've got 4 hydrogens on the left hand side. So what do I need? I need to balance them, meaning if I change this and multiply by 2, multiply this by 2, right? So if I multiply that by 2, so how many hydrogens am I having? I'm now having 4 hydrogens, so you cancel there, it's now 4 hydrogens. But look, the moment I changed the hydrogens, what also changed was the oxygens, because when I say 2 times 2 is 4 hydrogens, but oxygens, now I've got 2 oxygens and what? And I've got 2 oxygens, so which means here it's 2O plus, this is the 2 times oxygen. So in the water it's 2 oxygens, and the carbon dioxide it's O2, which is 2 oxygens. In total, what do I have now? I've got 4 oxygens. So which means I can come back here and correct it actually to say, since I have 4 oxygens, how do you make 4? You multiply that by 2. So 2 times 2O2, then it becomes 4 oxygen here, and even on the other side it becomes 4 oxygen. So this equation now has balanced to say CH4 plus O2 is 2 or H2O plus what? Plus carbon dioxide. So this is the what? The combustion reaction in excess oxygens. That's why they'll say oxygen here is in excess. Let's try another one, because the most important thing they will always ask you is to balance the equation. Remember, this is excess oxygen. Let's say I'm burning butane. Now, what is butane? Butane, remember, for alkanes, it's CnH2n plus 2. So for butane, it's 4, so it will be C4H10, which is 2 times 4 is 8 plus 2. So this is butane. So if I have butane, C4H10, and then it's combusting with oxygen, what do I get? I get water, H2O plus carbon dioxide. Alright, now let's do it the other approach now. Let's start with carbon. How many carbons do we have? On my left hand side, carbons, C4. So I've got 4 carbons. Let me use a different 4 carbons. And then on my right hand side, I've got what? 1 carbon. So which means I need to multiply by 4 here, so that I can also in simple make it 4. So you see, don't do it like this. It's not allowed. Don't come here and say, I want to put a 4 there. Now you have changed the molecule, because there is no molecule called C4O2. You see that? So whenever you are going to put a number, the number must be before. So it must be before that, so that it will still maintain as carbon dioxide. If you say C4O2, this is no longer carbon dioxide. It's another molecule. So don't create a dangerous molecule. It will explode in your face. You know, some of you will end up creating some nuclear molecules here. So don't come here and say, I want to create a molecule, I want to balance it. Hydrogen is 10, so I'm going to say H10O. You know, it will explode in your eyes, guys. So don't do that. So okay, you write the number before. So it's 4 carbon, my left hand side and my right hand side. So far so good. Now with that, let's look at the hydrogens. How many hydrogens? So let's balance the oxygen later. I think that's the best one. Deal with the oxygen at last. Don't start with oxygen, but deal with the oxygen last. Let's look at hydrogen. Hydrogen, I've got 10, but here I've got 2. So if I put 10 here, it will be 10 times 2, which is 20. So what must I put? I must put the number 5. See that? That's the number that I can put here, 5. So that I say 5 times 2, it's 10. So I will have 10 hydrogens, and then here also 10 hydrogens. So far so good. And then the last one, as I said, balance oxygen as the last. Look at your right hand side now, because the right hand side is balanced. To say how many oxygens? 5 times 1. So we have got here 5 oxygens. On my left hand side, look at it, 5 oxygen plus, because it's 5 times 1. You see, these two only affect hydrogen, so it's 5 times 1, which is 5 oxygen, plus 4 times 2. This is 4 times 2, 4 times 2 oxygen, which is 8. So you say 4 times 2, 8. 8 plus 5 is what? It's 8, 9, 10, 11, 12, 13. So you've got 13 oxygens. If you've got 13 oxygen atoms, so what do? Come on your left hand side and you write that number 13. But we know that 13 times 2 is 26. You divide by 2. Remember what it did? So that you say 13 times 2, 26. 26 divided by 2, it will still get us to 13. But of course, you don't leave your answer like that. What you do is to get rid of that particular 13. You multiply by 2 here. Now everything you multiply by 2. Each and every item you multiply by 2, so that you can get rid of that 13. Now 2, it will become, the final equation will be 2C4H10 plus 13O2. It will give me 2 times 5, it's 10H2O plus 2 times 4, it's 8CO2. This then becomes the final equation there. You can check it. How many carbons, how many hydrogens? Now you change these numbers now, because everything has changed. Let's look at how many carbons. 2 times 4 carbons, which is 8 this side, 8 carbons. What about on the right hand side? 8 times, you can see the 8 there, it's 8C. How many hydrogens? 2 times 10 hydrogen, which is what? 20 hydrogens. How many hydrogens? 10 times 2, which is simple, 20 hydrogen. How many oxygens? 13 times 2, which is what? We said it's 26. 13 times 2 oxygens, which is 26 oxygens. On the other side, we said 10 times 1, which is 10 oxygens, plus 8 times 2, and then 16 plus 10, which is 26 oxygens. You see that? It is balanced. That's how you balance that. So guys, you need to be comfortable. You need to be comfortable in dealing with that. Let's look at a question here that deals in a way with a similar part. It says butane is used as a gas in cigarette lighters. Write down the balanced equation for the reaction that occurs when the cigarette lighter is ignited. We just did it. So when you're igniting a cigarette lighter, remember they said butane is a gas used in cigarette lighters. So the word ignite means to burn. So that's when you say butane, which is C4H10 plus oxygen, you get what? Water plus what? Carbon dioxide. Are you with me? Then you do the thing that we did when we were balancing this side here. That's where you're going to say 2, 13, 10, 8. You see that? So you have to do that. To say here you have 2, you're balancing 13, 8, 10. I hope I did that properly. But you go through that process we did previously. And then says, what makes the reaction of butane suitable for use as a cigarette lighter? They wanted to say lighter. And then we said they did tell you about butane. What are they? They are highly combustible. Remember what they told us as a fuel. Number one, it is highly combustible. As a fuel, highly combustible, or it burns completely. It burns easily and completely. Okay, so that is the main thing. But the keyword there is highly combustible. Where am I taking it from? From this part to say, I think it's previously here when they said the alkanes are highly combustible and are valuable as clean fuels. You see, they are highly combustible. Alright, then the next one, what is it saying? Is the reaction exothermic or endothermic? We did establish that it is an exothermic reaction, and there's give reason for your answer. You can say because what it produces when you're burning these, they produce heat. Any reaction that produces heat is what? Is combustible. That's what you can see. You feel the heat that is produced is the reason why this reaction is exothermic. I know you want to say delta H. Delta H is less than 0. It's correct, but the question is, where do you know? How do you know? Like, did you measure it? But the fact that it's combustible or excess heat is produced, that's the thing. It says write a balanced chemical equation for the combustion of octane in excess oxygen. Let's do this one. I think it's an interesting one. We're talking about what? Octane. So it's very important for you to know the chemical formula for octane, the molecular formula. So now remember, alkanes is what? CnH 2n plus 2. You don't need to cram this. So now we're saying octane, you must know it's carbon number 8. C8 H 2 times 8 plus 2, which is C8 H 16 plus 2, which is 18. Right. So now we know we're dealing with that. So we are saying combustion of what? Of octane in excess oxygen. So I'll say C8 H18 plus oxygen. Excess oxygen always gives me water plus carbon dioxide. Are you with me? Then your duty now is to what? Is to balance. I said look at oxygen as the last. This is your last part to balance. Don't focus on it. Focus on the carbons and what? And the hydrogens. Let's start with the carbon. How many carbons do we have? There is a number 1 there. So 1 times 8, it's 8 carbon. So left hand side and right hand side. So how many carbon do we have? 8 carbons. On the right hand side, how many carbon? It's just 1 carbon. So what you do, you multiply by 8 to balance it. So it's 8 carbons, 8 carbons. So far so good. Then you continue. How many hydrogens do I have? 1 times 18, it's 18 hydrogens. And then how many hydrogens do I have here? It's 2. So because it's 1 times 2. So how do I make it 18? It's 9. Take 9 times 2. Because if it's already 2 here, I multiply by 9, I'll get 18. So 9 times 2, which is equal to 18 hydrogens. So I have managed to balance the hydrogens and the carbons. As I said, deal with the oxygen last. So let's now deal with our oxygen. How many oxygen do I have on my... Now, you can't say on my... This side is 2 only. So obviously it's not going to change. But what is interesting is this side, the oxygen, because you have been balancing both sides. But now, when you are balancing, oxygen was changing on the other side. So you've got here, oxygen, you can see it's 9. It's 9 times 1 there, which is 9 oxygen plus 8 times 2, CO2, 8 times 2, which is, what is it? 9 plus 16. So 16, is it 16 here? 16 plus 10 is going to be 26, so it's 25 here. 25 oxygen. So you've got 25 O oxygen atoms. Are you with me? So now the next thing that you need to do is to come here and say, I've got 25 oxygens, but you divide by 2. So that is 25 times 2 is 50 divided by 2. Are you with me? So with the oxygen on the other side, you'll be saying 25 times 2 over 2 oxygen. So that you've got what? 25 oxygen at the end. But now, that's not the final part. The aim here is to come and say, okay, I need then to multiply everything by 2. That's the reason. So what you're going to do, you're going to say times 2, even here, times 2, 1 times 2, it will become a 2. And then 9 times 2, and then 8 times 2. See that? Then you can now erase this part. 25 over 2 times 2, it will remain as what? As 25. Then 9 times 2, it will give us what? 18 here. And then lastly is 8 times 2, it will give us 16. That's how you do that. So that's how you balance that. You can check it on your own. Check again the carbons, the hydrogens and the oxygen. You'll see that the oxygens are balancing. For example, the hydrogens is 2 times 18, which is 36. 18 times 2, 36. You see, carbons 2 times 8, 16, 16 there. So the oxygens, we just balance them. So that's what you do. And then they say, write down the balance equation in insufficient oxygen. Very key now. When they are saying insufficient oxygen, so what we have is, let me erase this side. Now, insufficient oxygen means incomplete combustion. So what we have got C8. Let me use another one. I'm going to make it red intentionally because it might not be within your syllabus, but just appreciate incomplete combustion plus oxygen. When you talk about incomplete combustion, just know that you get carbon monoxide. It's water, not change. Let's start with water here. H2O will still be there, but instead of carbon dioxide, you get carbon monoxide. So this is carbon monoxide. Don't forget that, carbon monoxide. So when you do that, you do the same thing. We balance the carbon, the hydrogen, and then later the oxygen. So 18 hydrogens on the left, we've got 9 there, and then the carbon is 8. I put 8 there. Now how many oxygen I have? It's for here it's 9 times 1, it's 9 oxygen plus 8, which is 17. So it's 17 over 2, remember. And then after that you start multiplying by what? Start multiplying by 2. So you have 2 there, and then in here 2 times 17 over 2, you will have 17 here. You are multiplying by 2, so times 2 there, you will have 18 here, and then times 2 here, you'll have 16 here. Are you with me? So 2 times this, 16. So carbon monoxide, actually it maintained, the only thing that changed here was oxygen. That's why they said incomplete combustion. So you see that you use less oxygen. Look at that. You're using less oxygen. So it's carbon monoxide that is the main part. But now you need to know about this. They are saying which two gases are produced in 4.1 and 4.2 and what is their effect in the environment. In 4.1, excess oxygen, the gas is what? The gas produced is carbon dioxide, and then they're saying what is their effect on the environment. Remember, carbon dioxide, it leads to what? Greenhouse. It's a greenhouse gas and leads to global warming. Remember, carbon dioxide is one of the culprits of global warming. It's a greenhouse gas. Now what about carbon monoxide? Carbon monoxide also is a dangerous gas. It's toxic. This is a toxic gas. If it's inhaled, it will kill. So it's toxic gas, and also it causes acid rain. Carbonic acid, it causes carbonic acid, which is acid rain, and the acid rain, it affects buildings, it affects structures and all that stuff. So these are the questions you could have answered. So guys, we are done with the lesson, and I want you to join me in the next part where we are going to look at what? We're continuing looking at organic reactions, but in this case we are looking at esterification. You don't want to miss that. The formation of esters, the sweet smelling aromas. Hence I gave you this eucopos as a scent, the scent. So where or how does esterification comes into play? Join me in the next lesson. Remember, subscribe and ensure your notification bell is turned on. Thank you.